to Math with Miss Swartz. Today we are beginning our new unit over inequalities, and we're going to start with just a little intro. A lot of this you've probably learned, so that makes today pretty simple, but we want to make sure we understand some major differences, some major similarities between inequalities and equations, and then the types of things that we're going to be doing when working with inequalities, specifically graphing. So we want to make sure we have a good handle on that before we jump into solving inequalities. So let's get started with our first slide here. As you can see, I kind of have it broken down pretty nicely for us. So we have on here equation versus inequality and what our differences are. So we want to make sure that we understand, okay, here's an equation. This is what we spent the last 4 weeks looking at. And here's inequalities, and now this is what we're jumping over to. And the nice thing about it is they have a lot of similarities, more than just that we're going to talk about right now, especially when it comes to solving equations and inequalities. But for now, just looking at the similarities that we can see at the moment, we'll be talking about, let's see if I can move this, I need my pointer. Oh. There we go, now I got it. Grab my selector tool. Expressions, okay? So when we look at equations, and we may not have talked about this a ton, but when we have expressions, we're talking about this is an expression and this is an expression. We have two sides to the equation, so it has two expressions. It's made up of two expressions. And as you can see, over here with inequalities, that's the same case. We have two expressions on either side of the symbol. Okay, so that's kind of our similarity. Expressions is a big piece that looks a lot alike, but our differences come into play quickly after that because as we can see, they have different signs, and you can see where I wrote. But the signs are different. So when we're looking at an equation, you're going to see pretty much this as your option. You're going to see that equal sign. Okay? But when we're looking at inequalities, there's a few different options. Okay? We're going to see less than, and you may have heard of this as like a gator, like the alligator eats a bigger piece. Greater than, less than, sorry, I said less than here. This is greater than, this is less than, this is greater than or equal to, and this is less than or equal to. So these are the four types of signs that we could see if we're working with inequalities. The other major difference with inequalities, and sorry I have to go through this process again, is that our solutions are going to look a little different. So when we're working with equations, we've talked about a few different types of solutions. Mainly we've seen one solution as an answer to an equation. But the last couple days we've talked about equations that have solutions of no solution. And we've also talked about infinitely many solutions, or what we call IMS, so any real numbers or all real numbers. So these three options are going to be our solution options. When we talk about inequalities, we are going to be talking about a set of solutions. Okay, so this set of solutions is going to be made up of any number that makes the statement true. So in a lot of cases, there's going to be multiple solutions. Where over here, that's a little different than what we were looking at with equations. A lot of times we just had one solution. So if we look at our example, x is less than 5, any number that makes that true would be a solution. So 4, 3, 2, 1, on down the road until we can't stop anymore. Okay, so as you can see, the solutions look very different. So we want to know how to talk about, how to say and graph an inequality. And I need to move this stuff out of the way a little bit. So we're going to talk about, okay, look at an inequality, look at how you would think about it in words, and then look at how we would graph that inequality. Just so we can focus on one at a time, I'm going to put in a screen shade here, and we can focus in at this one first, and then we'll go through all of them, and these should all be in your notes. So if we look at this, make sure I have my pen working here. Kind of flip-flopping back and forth today. We have x is less than 5. So that, remember, you probably learned about inequality symbols. You talked about how the alligator mouth is going to eat the bigger number. Okay, well, we don't really talk about that once we get to, middle school. We want to kind of advance our language of mathematics a little bit. So in words, this would be any number less than 5. Okay, would be a solution to this inequality. So if we're going to graph that, okay, a lot of times what I like to do is put my number here kind of in the middle of the graph. So I have 5, and then I'm going to go, I want to keep it even all the way across, so I'm going to go up by 1s here in this case, and down. Okay, so now I'm going to graph this. Well, we want to graph and we want to represent any number that's less than 5. So in this case, we're going to have an open circle at 5, and we're going to talk about specifically the difference between open and closed circles. But you'll probably pick up on it as we do these 4 problems. And we want to graph anything that is less than 5. So we would draw our graph, we would shade in our graph with an arrow, or we could do it above, depending on how you like it. Okay. We're going to graph anything less than 5, and we can check that. Okay, if we pick out this number 2, is 2 less than 5? Well, it is, so that's kind of good. We can see that all our numbers going to the left there are less than 5. If we go down a little further, now we have x is greater than 7. Okay, so any number greater than 7 is kind of the words we would think. So in this case, I could put 7 in the middle, and I have numbers on the other opposite sides. Now I have an open circle at 7, and I want to shade all of the numbers that are greater than 7. So that would go to the right, or above, however you like to graph that. So I can check one of those numbers. Is 11 greater than 7? Well, yes, it is. So we know that all of these numbers are then going to be greater than 7. And we would represent that on a graph. Well, we talked about some other types of inequality symbols. We also have x is less than or equal to 12. So in this case, our words would say any number that's less than or equal to 12. So notice how this is different than just any number that's less than 5. So if we put 12 in the middle here, now I'm going to have a closed circle at 12 because 12 is in fact a solution. 12 is equal to 12, and that says it can be equal to. And then I'm going to shade anything that's less than. So if I check that solution, is 9 less than or equal to 12? Well, it doesn't have to be both. It just has to be one to make it a true statement. 9 is less than 12. So we know we're good there. And our last one, 20 is greater than or equal to, x is greater than or equal to 20. So our wording, sorry you can't quite read it on the screen, but any number greater than or equal to 20. Okay, so same concept. Draw our points in here. We're going to have a closed circle at 20 because it could be equal to 20, and it's going to be shaded to the right because it's going to be larger. Is 24 greater than or equal to 20? Yes, it is, so that would be correct. So notice a few things before we jump on to the next slide here. Notice that in all of these cases, our variable is listed first. And I'm never going to tell you you can't list it the other way, but this way is generally the easiest way we can list these things. Because if we say 5 is greater than x, that doesn't make a lot of sense. It's the same thing as x is less than 5, but if we write it like this, it's just hard to understand what that means for us. So we always want to list our variable first. Also, it helps us with graphing. Notice, in all of these cases, if our variable is listed first, the direction of our arrow corresponds with the direction of our inequality symbol if we think of it like an arrow itself. So here it's going to the left, here it's going to the right, here it's going to the left, here it's going to the right. So it is beneficial for us to list our variables first. So the last thing we want to wrap up with is, how do we know if we have an open or closed point? Okay. And then what about the shaded direction? So we're going to have an open point when our inequality symbols are either greater than or less than. Okay. And we're going to have a closed point when they are either greater than or equal to or less than or equal to. The shaded point includes the number. So for example, x is greater than or equal to 12. It includes this number that we're speaking about in the solution set. And then when we're talking about, okay, which way do we shade it? Do we shade it right? We're talking about greater than in that case. Are we shaded left? We're talking about less than in that case. Okay, so for example, if we have greater than 5, we will typically be shading to the right of 5, because if you notice, 1, our arrow is going that direction, but all of the numbers to the right of this on the number line would be bigger than 5. Same with less than. If we had x is less than 5, we're going to be shading to the left because that is where we would find numbers less than. This only works when the variable is on the left side of the inequality. So it's listed first, as we were talking about on the previous screen. So, as I said, you've probably heard of a lot of this before. This is probably a lot of review, but it's a great thing to have in your notes to get us started on this inequality unit. Get your notes checked, and we will talk to you about your assignment. Have a great day.